Good evening, good evening. Yes, Manpreet. Anjali, if we take 3 tons of bauxite, we get 1 ton of aluminium. That is called as weight loose industries. If I take 1 ton of cotton, I get 1 ton of thread. That is purely like, when two raw materials, if I use, if the weight keeps on increasing, then it is called as weight gain industries. Guys, today let us talk about oceanographies. Basically, in oceanography, the toughest part is done. Ocean currents, all those are done. We just need to look at some basic aspects. But here, I want you to remember whenever we use the term continent, that means it is made up of silica and aluminium. And when we say oceanic crust, it is made up of silica and magnesium. So you use the term continent, silica plus aluminium, oceanic, silica plus magnesium. Now everyone, look at this, guys. Look at this. If this is my coastline, guys, and if this is my water level, guys, we normally observe that this part is made up of silica plus aluminium. This part is made up of silica plus magnesium. That's why this will be called as continental. Okay, this will be oceanic. Now, guys, you tell me, if I go into the water, can I say till this particular part, do I have gentle slope, guys? Do I have gentle slope? Yes. This gentle slope area is called as continental shelf. It is called as continental shelf. And the steep slope area is called as continental slope. Gentle slope area is called continental shelf. Steep slope area is called as continental slope. Can you people tell me, is there possibility of sun's rays penetrating in this region? Remember guys, sun's rays will penetrate 60 to 77 meters. Okay. Sun's rays will penetrate 60 to 77 meter. Now you tell if this depth is 60 to 77 meter, can you have plants growing in the region? Can you have plants growing in the region? Yes. If you have plants, do they undergo photosynthesis? If you have plants, do they undergo photosynthesis? Yes. If there is photosynthesis, can we say carbon dioxide is absorbed and oxygen is released? Carbon dioxide is absorbed and oxygen is released? Yes. Whenever more oxygen is released, more fishes will come to that region. When more oxygen is there, more fishes can come. You tell me, if at all there is more fishes, can we say it is good for fishing? Can we say it is good for fishing? Okay, so a well-developed continental shelf, is good for fishing, Second, guys, I just want you people to think and tell me. Now, let me say, this is my mean sea levels. Okay, this is the average sea level. Okay, due to a pyrogenic movement, that is downward movement. Okay, this part went down, and water which was present till here came till here. Okay, is you tell me, if land goes down, can I call it as submergence? Everyone, can I call it as submergence? And can you people tell me, water level has increased, this particular part from here to here, what do you call it as, guys? Can we call it as continental shelf? Can we call it as continental shelf? Yes. So can you tell how shelf is formed? Can you tell how shelf is formed? Due to submergence. Due to submergence. Can you open India map? Can you open India map and see this particular part, guys? Do you have more continental shelf in this region? White patch will be more. Check once. White patch will be more. Check once. Can I say you will have more continental shelf? Yes. Now, everyone, see this, guys. Rivers will start depositing the sediments. Rivers will start depositing the sediments. And all those sediments are like this. Okay. So if that is the case, guys, if that is the case, can I say the new continental shelf is like this? This is your new continental shelf. Yes. Can I say this continental shelf is formed due to deposition? Is it formed due to deposition? Yes. Can you check here, guys? This particular part. Do you have more white patch? Yes. Very good. So now, can you see Krishna, Godavari, Delta, white patches are there? Because those white patches indicate continental shelf. And how are continental shelves formed? Continental shelf is formed either due to submergence or due to deposition or due to deposition. Everyone, write along with me. Bottom topography of oceans. Bottom topography of oceans. Okay. In that, first one, continental shelf. From the coastline towards the ocean, we observe gentle slope. From the coastline towards the ocean, we observe gentle slope called as continental shelf. This depth is less or shallow when depth is still 60 to 77 meter. Solar insolation penetrates and helps in growth of phytoplanktons. Helps in growth of phytoplanktons. Due to this, oxygen is released and we observe more number of fishes. Oxygen is released and we observe more number of fishes. So, well developed continental shelf is good for fishing. Shall I move? Continental shelf is either formed due to a pyrogenic movement, that is submergence, or it is formed due to exogenetic forces, that is deposition. Next, continental shelf is very well developed in Siberian region, whereas it is almost absent near Chile region. Everyone, you see now, if I have land like this, when rivers flow like this, will they deposit the sediments in the trenches, guys? Will they deposit the sediments in the trenches? Yes, and when they are present in the trenches, can we say the sediments are lost through trenches? And if sediments are lost through trenches, will you have continental shelf or less continental shelf? Less. Can you open South America map? Can you open South American map? Can you see beside Chile physical map? Yes. Yes, very good. Can you see Peru Chile trench there? Everyone, can you see? Yes. So, because of trenches, we do not have continental shelf much. See, ma'am, wherever continental shelf is less, there you will not have, like, continental shelf. Yes. Done, guys? Shall we see next one? Guys, what exactly is continental slope, guys? Is it gentle slope or is it steep slope? Gentle slope or steep slope? Steep slope. Good. You tell me, mm, like, plain area, will you have more people? Plain area, will you have more people? Or like, what do you call it as? Mountains, will you have more people? Plain area, will you have more people? Mountains will have more. Plain area will have more people. Very good. Very good. Okay. If this is the case, everyone think and tell. If plain area has more people compared to what do we call as steep slopes. You tell me continental slope will have more, or will you have what we call as continental shelf will have more this? Continental shelf is gentle, so you get more. Okay. Yes. Kamal Pal. Okay. Kamal Pal. Western side, not everywhere. Uh, North America, South America, you will have less because trenches are present. Wherever trenches are there, normally you will have less continental shelves. Okay. You see, continental slope. Please write. It is steep slope extending from the steep slope extending from continental shelf till ocean basin. It is transition between continent and ocean. In this region, as slope is steep, we observe less pieces. We observe less pieces. This now you see, I have continental shelf, I have continental slope, okay, and I have a flat area. Here I will have continent and I have ocean. So here I have trench. Guys, can you tell me where will you have earthquakes and all, in one or two ways? Trenches, will you have earthquake? Yes, yes. Can I call, if earthquakes are there, active boundaries? If earthquakes are there, can I call it as active boundaries? Yes. Okay. Now you tell, if sediments are deposited, will it fall in the trench? Will it fall in the trench? And will it be lost through the trenches? Yes. But here you tell me, can I say they all may accumulate here? They all may accumulate here. So when they accumulate, it is called as continental rise. If they enter into other areas, asthenosphere and all, it is called as continental, trenches here. When they accumulate, it is called as continental rise. Okay, whenever they accumulate, it is called as continental rise. Do you get the difference? If active boundary is there, trenches will be there. If passive boundary is there, you will have sediments accumulating. That sediment accumulation is called continental rise. Continental rise. Whenever there is passive boundary between continent and ocean we observe that sediments accumulate to form continental rise. Can you tell me why it is called continental? If I use the term continental, what is the meaning of that? What is the meaning of that if I'm using the term continental? What will it be made up of? No, no, ma'am. What will it be made up of? Silica and aluminium. Very good, very good. Everyone see here? What is this called, guys? What is this called? Continental shelf or slope? This part. Continental shelf. What is this, guys? What is this, guys? Continental slope. Continental rise. Everyone see here. You may observe, ma'am, passive boundary means where there is no earthquake. Where there is no earthquakes. Trenches are absent. Okay. Yeah. You see, guys, if you have like this, is this a flat plane, guys? Is this a flat plane? This flat plane is called abyssal plains, guys. Abyssal plains. This is called continental rise. This is called continental slope. This is called continental shelf. Okay. Now you see, guys, here, everyone, if there is group of mountains present below the sea level, what do you call it as, guys? If there is group of mountains present sea level, can we call it as ridges? Can we call it as ridges? And if you have something above sea level, if you have something above sea level, what do you call it as? Above sea level is called as islands. Okay. Guys, if you have convergent boundary, can I say you will have some of the deepest parts of the continents? Okay, deepest part of the oceans, not continents. Can we call them as trenches? Trenches? Yes. Yes. Can you people tell me, if you have isolated mountain, if you have isolated mountain, what is it called as the single mountain? If you have, it is called sea mount. If you have flat topped sea mount, it is called as what? Guyats. Okay. Can you draw this, guys? Can you draw all this once, everyone? Single isolated mountain is called as seamount. Flat topped seamount is called as trenches. Can you draw this? Abyssal plains basically means, ma'am, flat areas in the oceans. They are called as abyssal plains. Okay. Done, everyone? Yes, Anjali. Abyssal plain. It is flat surface on the oceans which is filled with sediments. If trenches are more, sediments are less, because sediments are lost through trenches. Done, guys? Sediments are lost through trenches. Okay. Now, ridges and islands. A group of mountains present below sea level is called ridges. If an island, sorry, if a mountain if a mountain is present above sea level, then it is island. Faiza, sediment loss is also not occurring immediately. It will also take lot of time. Okay. The way oceans trenches form takes lot of time. This also takes lot of time. Guys, can you tell trenches, are they associated with convergent boundary or divergent boundaries? Trenches near convergent boundary, we observe deepest part of the oceans called as trenches. Near convergent boundary, we observe deepest part of the oceans called as trenches. Mariana Trench is the deepest trenches. Mariana Trench is the deepest trench. Okay. Next, everyone, think and now you see. Sea mount. What is sea mount? Isolated mountain below sea level is called sea mount. Isolated mountain below sea level is called sea mount. Guyats. Flat topped sea mount is called guyot. Flat topped sea mount is called guyot. Done? Guys, this is bottom topography of oceans. Next chapter is temperature in the oceans. What is temperature? It is degree of hotness or coldness of a body. It is degree of hotness or coldness of a body. Okay. Now, whenever I talk about temperature, I need to talk about horizontal distribution of temperature. Yes, ma'am, this is new chapter. Horizontal distribution of temperature. Guys, can you tell me where will you have highest temperature? Where will you have lowest temperature? You horizontal means latitudinal. Okay. First one latitudinally. Can you tell me where will you have highest temperature? Where will you have lowest temperature? Good. We observe highest temperature near equator and lowest near poles. That is That is, temperature is inversely proportional to latitude. Do you all agree, guys? As temperature latitude inversely proportional to temperature. As latitude increases, temperature decreases. Second, influence of ocean currents. Influence of ocean currents. Guys, okay. See and tell me guys properly. Can I say in this region you had Gulf Stream, guys? Do you recollect Gulf Stream current in this region? Yes. Do you recollect in this part you had North Atlantic Drift? Do you recollect here you have Canary current? Do you recollect in this part you have Labrador cold current? Guys, can you tell western side of the oceans, which water is there? Western side of the oceans, warm water. Eastern side of the oceans, which water is there? Cold. Okay. Can you see here, guys? Can you see here? West and east. Can you tell me now which side cold water, which side hot water is? West side cold, east side warm. Can I say lower latitude is different from higher latitude, guys? Can I say lower latitude is different from higher latitude? Yeah, you're right. In lower latitudes, in lower latitudes, temperature on the western side of the oceans, on the western side of the oceans are warmer and eastern side of the oceans are colder. Western side of the oceans are warmer, eastern side of the oceans are cooler. Next, in higher latitudes, in higher latitudes, in northern hemisphere, western side of the oceans are cooler and eastern side is warmer. Okay. Third is distribution of land and water. Yes, can you tell me which hemisphere has more land? Which hemisphere has? Because in southern hemisphere, ma'am, there is no land in below region. You check once ocean currents. Yeah. Northern hemisphere has more land. You tell me, if more land is there, temperature, will it be more or will it be less, guys? Temperature, will it be more or will it be less? More. Southern hemisphere, you tell me, will temperature be more or will it be less? So can we say southern hemisphere temperature is lesser compared to northern hemisphere because of distribution of land? Okay, you're right. In northern hemisphere, average temperature of oceans are more compared to southern hemisphere. Northern hemisphere average temperature of oceans are more compared to southern hemisphere. Because land is more in northern hemisphere. Guys, enclosed seas. Guys, temperature of Red Sea is more or temperature of Atlantic Ocean is more, guys? Temperature of Red Sea is more, temperature of Atlantic Ocean is more. Why? Can I say Red Sea is surrounded by, yeah, Red Sea is surrounded by land? Yes. Guys, you have a lake here called Lake Baikal, guys. Lake Baikal, okay? So you tell temperature of Lake Baikal is more or Atlantic Ocean is more, guys? What will be more? Okay. No. See, yes, that is the confusion. Please see here. Is Red Sea covered by land? Is Red Sea covered by land? Is Baikal covered by land? Yes. Baikal is surrounded by cold land, Siberian region, cold land. Red Sea is surrounded by hot land. So now you tell, if land is cooler, can I say Lake Baikal will be cooler? If land is hotter, can I say yes? Yes. Shall we see? In lower latitudes, temperature of enclosed seas is more compared to open oceans because land is warmer. Example, Red Sea is warm compared to Red Sea is warm compared to Atlantic Ocean. Fifth, sorry, in higher latitudes, in higher latitudes, temperature of enclosed seas is less than temperature of open ocean. Lake Baikal is cooler than Atlantic Ocean. Done? Okay, so all this is horizontal distribution of temperatures. Now, vertical distribution of temperature. Everyone understand this? I'll give time to draw. Let me say this is surface, this is bottom. Okay, now guys, you tell me, cold water, is it denser or lighter? Cold water, is it denser or lighter? Denser. Denser means will it settle at the bottom or will it be present above us? So guys, below 2000 meter, below 2000 meter or below 2 kilometers, cold water has accumulated in the oceans. Cold water has accumulated in the oceans below 2 kilometers. From where to where? From equator till poles. Okay, from equator till poles. Everywhere cold water of same temperature has accumulated. So minus 10 degrees Celsius, minus 5 degrees Celsius, 0, 5, 10, 15, 20. Okay. So temperature is same throughout. Okay. Now you tell me guys, sun's rays penetrates till what depth is? Sun's rays penetrate till what depth? Which meters? 60 to 77, correct. So you tell me, will sun's influence be there only till 60 to 77, or it will be little deeper also? See, direct insolation, that is sun's rays penetrate till 60 to 77, but light will be there till 200 meters. Till 200 meters, light will be there. Now I want you to tell me A and B. Sun is heating from the top. Sun is heating from the top. Which layer will be more hotter? Which layer will be less hotter? Which layer will be more hotter? Which layer will be less hotter? A will be hotter, B will be cooler. Correct? Yes. Can I say as I go deeper, temperature decreases? Can I say as I go deeper, temperature decreases? Yes. And can I say in this region, temperature is almost constant? Can I say temperature in this region is almost constant? Yes. So this layer is called as uniform layer of temperature. This layer is called as uniform layer of temperature. This layer is called as photic zone. This layer is called as photic zone. In between layer is called as transition layer, called as thermocline. Thermocline. Okay. In between layer is called as transition layer, called as thermocline. Do you understand this? Ocean is basically divided into three layers: photic zone, thermocline layer, uniform layer of temperature or uniform zone of temperature. Now, 0 to 200 meter, it is called as photic zone because it is under the influence of the sun. As we go deeper, temperature decreases. And below 2 kilometers, we have uniform layer of temperature, where temperature is almost, where temperature is almost uniform. In between these two layers, we have a transition layer called as thermocline layer. Can you draw this, guys? Even if you go deepest of the oceans, you will have minus 10 degrees Celsius. Draw this. Done? aphotic layer is present till bottom of the oceans. Done? Okay. Yes. Yes, Anil. Yes, yes, Parveen. Vertically, oceans are divided into three layers. First one, photic zone. It extends from Earth's surface till 200 meters. Solar insolation penetrates till 60 to 77 meter, but but its influence will be there till 200 meter. Here, temperature decreases with depth. Second, thermocline layer. It is transition zone between photic and zone of uniform temperature. Here, temperature decreases with depth. Here, temperature decreases with depth. Zone of uniform temperature. It extends from 2 kilometer till ocean bottom, where cold and dense water has accumulated and it is present from equator to poles. Guys, this is temperature of oceans, guys. Temperature of uh, Anjali, near poles it will vary. Near poles from top to bottom you will have cold water only. But in all other layers that would be there. Okay. Because this is temperature chapter. Temperature in atmosphere we have already seen. We have salinity, guys. After salinity we have waves, tides, tsunami. Okay. Waves, tides and tsunami. Salinity. Okay. What is salinity? Salinity means, guys, it is amount of dissolved. It is amount of dissolved not salts, inorganic minerals. Inorganic minerals in water. It is amount of dissolved inorganic minerals in water. It is represented in percentage or parts per thousand. See, guys, if denominator percentages per 100 per thousand, that is 1 liter is equal to 1000 ml, right? 1 liter is equal to 1000 ml. So as it is 1000, we normally use the term like, parts per thousand. Percentage means 100 ml, parts per thousand means 1 liter, 1000 ml. Now, when I look at this, guys, it is represented in percentage or parts per thousand. Fresh water will have 0 to 5 parts per thousand, guys. Brackish water will have 5 to 30 parts per thousand. Saline water will have greater than 30. Yes, Lakshmi. Parts per thousand. Today, people also call brine water. Very high salinity is called brine water. Brine water will have 35 parts per thousand. Brackish means in between. In between fresh and salt water is brackish water. Sorry. Done, everyone? Then, guys, ocean will have sodium chloride almost 70%, guys. Within salts, sodium chloride has 70%. So highest salinity is sodium chloride, common salt. Okay. Can you all tell me how salts might have entered into the ocean, guys? Sources of salinity. Can you people tell me? Yeah, ma'am. Water means how did it go? Yes. Many people use it to believe that river erode sediments and add it to water. Okay, they thought this is the main thing is, but river carry calcium sulfate and ocean has sodium chloride. Can I say rivers have different salts and ocean has different salts? Can we say this, guys? Yes. Yes. Second. Guys, can I say from volcano, dust particles, pyroclastic minerals may join, may enter? Can I say meteor burning may add salinity? May add salinity? Guys, you tell me offshore winds from land to sea will add salinity? Can I say wind will carry some dust and all and will add salinity? Done, everyone? Yeah, Anjali, that is the question. Even world don't know about it. That's why we are thinking of all other aspects. Okay. Next is factors affecting salinity. Factors affecting salinity. Can you tell me if evaporation increases, will salinity increase or decrease? If evaporation is more, will salinity increase or decrease? Can I say as evaporation increases, salinity increases? So, evaporation, Kamalpal, evaporation means fresh water is removed. Parveen, see ma'am, in what do you call as in a glass of water, I have water filled with the salts. Okay, filled with the salts. You tell me if fresh water is removed, If fresh water is removed, can I say salts will be left behind? So salinity increases, Parveen? Yes. Guys, if precipitation increases, what is going to happen is, if rainfall increases, will it add fresh water or will it add salt water? Fresh water. Rainfall is fresh water. As precipitation increases, salinity decreases. So precipitation is inversely proportional Yes, Simran, very good. Salinity remains same, but water particles will increase and decrease. Lakshmi, can you drink rainwater? Have you ever consumed it? Rainwater you can drink, ma'am. It is fresh water. Okay. Next is, guys, you tell me, will river has fresh water or salt water, guys? Will rivers have more of fresh water or salt water? Good. No, Simran. Simran. See, guys, rivers will have just 1 or 2% of salts. Remaining will be fresh water. So you tell me, near mouth of the river, near mouth of the river, that is where the river enters into the ocean, near mouth of the river, fresh water enters and salinity decreases. So you tell me, Bay of Bengal will have more salinity or Arabian Sea will have more salinity, guys? Arabian will have more salinity because Bay of Bengal will have more rivers entering. Good. Guys, you tell me, winds. Can I say onshore winds reduce salinity and offshore winds increase salinity? Everyone, please understand what is the meaning of this. Okay, when wind blows from sea to land, guys, okay, waves will come towards the sea. When wind blows from sea to land, waves will come towards the sea, towards the land. Okay, so when waves are coming towards the land, waves will hit the land and it will deposit the sediments. Okay, and whenever winds blow from land to sea, okay, what is going to happen? Sediments are deposited into the ocean. So you will have these type of aspects. Okay, onshore reduce salinity, offshore increase salinity. Now, note, guys, Lake Van, Lake Van in Turkey has highest salinity in the world, guys. Highest salinity in the world. Second is Dead Sea. Dead Sea is second highest. Lake Superior in US is largest freshwater lake. Okay. Lake Superior in US is largest freshwater lake. Shall I move? Lake Baikal is deepest freshwater lake in Siberia. Yes, Sumaya, right. Okay. Guys, so this is about salinity. We need to talk about the next chapter, waves, tsunami, tides. Okay. Waves, tsunami, and tides. Okay. Yes, Saminder. No, no. Waves, tsunami, tides. Next chapter is next chapter. Is take break, like Guys, let us say a local wind like sea breeze hits the waters. The area where they hit is known as fetch. Area where they hit is known as fetch. Now you tell me, the place where the water hits, the place where the air hits the water, will there be a depression in that region, means? Will there be a depression? If water is there and if we tap on it, will there be a depression? Yes. If you have a depression, can I say the water rises? Can I say the water rises like this? Wherever you splash the water, yes, if you splash the water, will the water rise like this? Will the water rise like this? Yes. Now you tell, when it falls down, it falls down due to gravity. Okay, it falls down due to gravity. The place where it falls, can we say again? Can we say again? The waves will start moving. Guess you see here. I'll just tell you. Uh, I have a swimming pool. Okay, I have a swimming pool, and I tap at one part of the swimming pool. Can I say if I keep on tapping, can I say it keeps on moving this? Can I say it keeps on moving from that particular part? Yes. Do you need to go and tap everywhere? Do you need to go and tap everywhere? Or if you tap at one place, waves will go in all the directions. If you tap at one place, waves will go in all the directions. So here, what is happening? Wherever I tap, in that particular part, the water will go down, it will raise. And the other place where it hits, water will start going down. Water will start going down like this. Okay. So from wind to water, energy is transferred. And when the waves will hit, what is going to happen? Energy is transferred, but the particle will come back. You see, water particle will go like this and come back. Water particle will go like this and come back. So what is it that is moving? Whatever is moving is energy. Whatever is moving is energy. See guys, whenever waves are there, what will move? Energy will move. Water will not move. Water will go around and come back. But you may get a doubt, sir, if I go to a beach, what I normally observe is the waves will come, and the waves will come front and go back. Have you seen in the beaches the waves will come front and go back? Yes. That is because the place where the waves hit the land is called as breaker. Breaker. After breaker, the waves will travel like this. Here, how is it traveling? It is moving in a circular manner. Here, how is it moving? It is moving in a circular manner. But when it comes to this, it drags back. goes like this, drags back. Because can you check in this particular part? It is moving ahead and coming back. This is circular, this is circular. Can you see this is elliptical? This is elliptical. So guys, in this part, water will move, energy will move. But in this part, energy will move and water doesn't move. Energy will move and water doesn't move. This is called oscillation. This is called wave of oscillation. This is called wave of translation. Yeah, ma'am, wave is just transfer of energy, ma'am. Okay, you tell me now when I'm talking, is energy coming to you or particles coming to you? Energy. Energy itself. Energy itself is what? No, no, ma'am. What I'm trying to tell is, see, when you tap, how did you generate a wave? How did you generate a wave? You just tap at the water. Do you agree? If you just tap the water, yes, yes. So this water, if it travels till there, can I say energy reduces? Energy reduces because if water itself goes, you need that push. You need that additional push. If you are not giving additional push, then what is going to happen? Here, everyone see here, in this particular part, here depression came. Okay. Now you see here, has it reached to its maximum position? Has it reached to its maximum position? And after that, when it comes down due to gravity, will it hit the water again? When it comes down due to gravity, will it hit the water again? Yes. From there, new wave goes, but water will come back. Okay. From there, new wave will start because energy from this wave is transferred to this. Okay. Can you draw this, guys? Draw this. Hayat, last class, Hayat. Last class of geography, ma'am. That I don't know. Done with this? Heat island and other topics I have discussed, ma'am, that will be covered in environment, it seems. That's why. Yes, yes, yes. Draw this, guys. Guys, all the important points where explanation is required, we have seen, guys. Okay. Population, settlement, these type of issues basically has some problem, guys, because we do not have new data. As we do not have new data, there is no point in wasting your time on that. Done, guys? You can write the place where wind hits the water is called fetch. Near fetch, energy is transferred from near fetch, energy is transferred from wind to water. Okay. Near fetch, energy is transferred from wind to water. From here, waves are generated and they will transfer towards other regions. In waves, we observe wave of oscillation where particles don't move but energy will move. Particles will move in a circular form. Particles will move in a circular form. See guys, I will take one session completely on previous year questions, current affairs and all this. Okay. That will be done separately, not under this. So don't worry about all those aspects. Ma'am, let other subjects start, ma'am. Let me first complete this. Like, one session I'll take current affairs and all, which will be in YouTube. So don't worry about it. Mettur in Tamil Nadu, not in Odisha. No, Saminder, today's last class. The place where waves hit water the place where waves sorry hit land is the is known as breakers. From the breakers, waves will move in elliptical orbit where there is wave movement and energy movement. That is known as what? Wave of translation. Done, guys? Tsunamis. Guys, Anjali, just you need to look at the names now. Nothing beyond that. Just look at the names. Okay. Guys, you tell me now. Sure, ma'am. Sure, ma'am. I'll take Shweta. Everywhere you have swimming pool. Okay. We'll take a very big rock. We'll take a very big rock and put it at one place. Okay. We'll put it at one place. So you tell me, if I drop a rock suddenly, can I say the water will rise in that particular area, guys? Yes. Huh. Will the same height continue everywhere, or will it reduce as we go other side? Guys? Will it reduce as we go other side? Can I say it reduces slowly? See, very big swimming pool is there. If I put one side, it increases, other side, it keeps on reducing. So now, let us think about trenches, guys, okay? Let us think about trenches. Because you tell me, near the trench, will the area be smooth like this? Or is there possibility of some like land and all like this? Can there be a mountain, sea mount, anything can be there here? Everyone? Yes. Now you tell some resistance is there. Yes. Now you tell, when I press, see this, when I press, is there possibility that it raises, guys? Is there possibility that it raises? Yes. Okay. Is the land rising above? Is the land rising above? Is this area rising above? Yes or no? Okay. If this is oceanic, if both are oceanic, I'm not talking about land, both are oceanic. You tell me, if it goes like this, will there be movement of water upward, guys? Will there be movement of water upward? And if there is movement of water upward like this, so what is going to happen? You check here. Guys, you tell, there is a disturbance resistant here. This moved like this. Can I say the waves will go like this, guys? Can you see? Can you see this? Guys, can I call this as crest? Can I call this as trough? Crest, trough. Can I say trough means withdrawal of water? Crest means withdrawal of water. Trough means, trough means withdrawal of water. Crest means coming of water. Everyone? Trough means withdrawal. Crest means coming. Can I say, ma'am, waves, when you take waves like this, anticlines are called as crest, synclines are called as trough. Okay. So whenever waves move, anticlines are called as crest, synclines are called as troughs. Everyone, do you get this? Do you get this now? You draw this, guys. Parveen, everything will be on Byju's itself now. Shall I move? Right? Tsunami means harbor waves, and it is a series of waves caused due to displacement of large volume of water generally in an ocean or a large lake. Earthquakes, volcanoes, underwater explosions, landslides, glacier calving means guys big glaciers breaking and falling. Glacier calving, meteorite impact will will lead to tsunami. It is mainly caused because it is mainly caused because of displacement of water. Ma'am, that is because trough is coming. Yes. Glacier calving means huge block of ice if it breaks and falls into water. As trough comes first, water withdraws normally before tsunami. before tsunami. Okay. With tsunami, they will never ask you question only, like, if it is 20 years, 30 years, tsunami may come. Else normally tsunami is not asked. Guys, I want you to know, waves are mostly asked, or waves are mostly created by local winds. Tsunami is created due to endogenetic forces. Waves are due to local wind, tsunami is due to endogenetic forces. Ocean currents is due to planetary winds, and tides are due to gravitational force of moon and sun. Gravitational force of moon and sun leads to tides. Fine. Did you write? See this. Now, guys, first I'll explain some concepts. Earth. You have sun. You have moon. Guys, gravitational force is basically given by G m1 m2 by d square. Okay. So can you tell me whose gravitational force is more on Earth? Whose gravitational force is more? Moon or sun? Okay. Mass wise, whose it should be more? Sun. Distance wise, whose it should be more? Distance wise, whose it should be more? Yes. See, uh, I will take okay, a small magnet like this. I'll take a small magnet like this. I'll keep it closer to the earth, closer to the iron. Can I say the magnet attracts? Can I say the magnet attracts? Now I will take a very big magnet. I'll take a very big magnet and keep it far. Keep it far. Can I say influence is less? Can I say influence is less? Yes. So sun's influence is 20%. Moon influence is 100%. Sun's influence is 20%. Moon's influence is 100%. Okay. So can you tell me which one's influence is more? Which one's influence is more? Moon. Good. Everyone, Earth is there. Moon is there. Okay. Guys, on Earth, apart from atmosphere, can you tell which is the loosely attached one? Which is loosely attached one? Can we say water? Water is loosely attached. Yes. Everyone, now you check. This is water area. Okay. So can you people think and tell? Okay. Think this carefully and tell. Due to moon's gravitational force, is there possibility of water going towards the moon? Is there possibility of water going towards? That means little bulge will happen. Yes. Okay. But on water is Earth's gravitational force more or moon's gravitational force more? On water, whose is more? Earth. If moon's gravitational force is more, it should have gone towards the moon. If moon's gravitational force is more, water should go towards the moon. Is water going completely towards the moon, or is it pulled back? Is it pulled back by the Earth? Everyone, is it pulled back? Yes. Can I say for every action there will be equal and opposite reaction? Yes. See here everyone. If this is the moon, okay, water is pulled towards the moon. But what Earth does, Earth will pull it back. You tell me, if Earth pulls back, we can't see it, okay? We can't feel it properly. If Earth pulls back, is there possibility of, for every action, equal and opposite reaction to occur? Yes. So if water is pulled this side, there will be same amount of water bulging this side. If water is pulled towards the moon, same amount of water is pulled back. Guys, can I say there will be high tide here? So can I say there will be high tide here? You tell me. I have high tide this side, I have high tide this side. Here and here. Will I have low tides? I will have low tides. Guys, this is not poles. Okay, this is not poles. This is sides. Here I have high tide. Here I have high tide. Here I have low tide. Here I'll have low tide. Okay. So, guys, this position is called zenith position. This position is called as nadir position. One side of the earth facing the moon is called as zenith position. Other side of the earth which is away from it is nadir position. So my question to you is, can you tell me tides are occurring due to what, guys? First one, is it gravitational force of moon acting on it? Yes. Second, is there zero gravitational pull of sun, or is it less gravitational pull of sun, guys? So as it is less, sun is also included. If it was zero, we wouldn't have included sun. Okay, gravitational force of moon is responsible, gravitational force of sun is responsible. Third, guys, What is Earth's forces? What is Earth's forces? Earth's forces are called as centripetal force of Earth, centripetal force of Earth, centrifugal force of Earth, centripetal force of Earth, and centrifugal force of Earth. Okay, very good. Then guys, then you tell me, do you recollect I told you near Gujarat you have port like this, so tide height increases. Do you remember that? Do you remember that? Yes. So shape of coastline, yeah, shape of coastline is important. Do you all agree with me? Yes. Next, guys, you tell me, will you have tides above your house or will you have it only in oceans? No, ma'am, I'm telling you, will you have tides in the ocean or will you have tides in water tanks, lakes, and all? Ocean. So, what is important? Depth of ocean water is important. Can you write this, guys? What is tides? Periodic rise and fall of water. Periodic rise and fall of water. You can't see this periodic rise and fall of water. Yeah, Kamalpal, if you have coastline like this, more water will come, height increases. I explained it with respect to Kandla port. Yes, done. Until one force is acting outside, one force will be acting inside. Yeah. Can you draw this? Ma'am, if less water is there, gravitational force on that water will be more. If more water is there, gravitational force will be less. That's it. Centrifugal outside, centripetal inside. Yeah. Zenith means towards the moon. Nadir means away from the moon. This is zenith rays. Okay. Guys, you see now types of tides. Types of tides. Guys, diurnal tides, semi diurnal tides, mixed tides. Okay, see guys, everyone. Uh, guys, I have water here. I have water here. Exactly opposite also I have water. Okay. I have water here. Exactly opposite also I have water. So you tell me, if there is a high tide, if there is a high tide, will I get high tide back also? If I have high tide, will I get high tide back also? So what is going to happen? There will be one high tide this side, one high tide this side. Okay. Now I am talking about below India. Now India came back. Okay, India is exactly back. Now you tell here, if I have high tide, will I have high tide back? If I have high tide here, will I have high tide back? So can I say India will have high tide during zenith position. India will have high tide during nadir position. Do you agree with this? India will have high tide during zenith position. India will have high tide during nadir position. See guys, in a day, if we observe, two high tides and two low tides, then it is called as semi-diurnal tides. Okay. Now you tell, one side ocean is there, another side land is there. One side ocean is there, another side land is there. You tell me, will land go back? Will land go back? Or only water will go back? So in a day, if we have one high tide and one low tide, then it is diurnal tides. Okay. In a day, if you have only one high tide and one low tide, it is called as diurnal. In a day, if you have two high tides and two low tides, it will be called as semi-diurnal. Okay. Guys, you tell me now, one side, depth of ocean is more. Another side, depth of ocean is less. You tell me, will you have same height both the sides, or will you have different heights? Depth is different in both the places. So will you have same? Okay. Anjali, guess just a minute. Diurnal, I'll explain. Okay. See guys, for Earth, it takes 24 hours to come back, right? Now you are the moon. This part got high tide, but behind it did not get. Now I'll turn. You got land. Okay. Now the part which you saw before is in nadir position, but land is here. Now you tell, will there be moon's influence on the land? Will there be moon's influence on the land? Anjali, will there be moon's influence on the land? Will land go? Lakshmi, will land go? No. If land doesn't go, can I say no high tide this side? No high tide this side? That means no high tide behind also. So can I say this place got high tide only when it was facing the moon? Yes. Okay. When depth of water differs in zenith and nadir position, then height of high tides would differ. Then it is called mixed tides. Done? See guys, if you take Earth here, moon is not stationary. Moon will be moving like this. Same moon will be revolving like this. Now let me assume this is sun. Okay. See guys, can I say the side of the moon which sees the sun is day, the other side is night? Do you agree? The other side is night. Night means dark. Night means dark. Can I say for Earth moon is not visible? Guys, exactly straight is eclipse. I'm not talking about eclipse, okay? Yeah. Moon is not visible. Can I call it as new moon, guys? Okay. Can I call it as new moon? Now you see here. Can I say this is day side, this is night side? For Earth, can we see day side of the moon? For Earth, can we see day side of the moon? Yes. This is called full moon. Full moon. Okay. Guys, when sun and moon are on one side of the earth, it is called as conjunction. When sun and moon are on either side of the moon, okay, ma'am, exactly straight will be eclipse, ma'am. Exactly straight will be eclipse. But okay, when sun and moon are on the opposite side, we call opposition. Okay. Can you see here? Sun, earth, and moon are perpendicular to each other, guys. Sun, earth, and moon are perpendicular to each other. Then it is called as quadrature. Quadrature. Do you understand the positions? Do you understand the positions? Okay. Can you draw this, guys? Yes. Can you draw this? There are other positions also, guys, not required. Yeah. Syzygy means when sun, earth, moon, everything is in straight line, we call it syzygy. Yeah, I'll give you some in there. Did you write? You see here, when sun and moon are on one side of the earth, then it is called conjunction. During conjunction, during conjunction, we have new moon. When sun and moon are on opposite side of the earth, then it is called opposition. During opposition, we have full moon. When sun, earth, and moon are perpendicular to each other, then it is quadrature. Okay. Yes, now my point is, okay, write this, I'll tell you. See this. Guys, you see sun, moon, earth, sun, earth, moon. In both the cases, can I say, like, gravitational force of sun and moon, are they acting in the same line or opposite lines? Are they acting in the same line? When they act on the same line, will they add? When they act on the same line, will they add? Will they add? Will it increase? Will it increase gravitational? Will it increase tide height or will it decrease tide height? Increases. Okay. You see? Yeah. I'll erase this. New moon and full moon, I will erase. Now you tell. Can I say here they are acting in opposite direction? Here they are acting in opposite direction. So can I say overall height decreases? Overall height decreases. See this. I will have spring tides. During full moon and new moon, tide height increases because gravitational force of sun and moon will be acting on the same line. So height of high tide increases and it occurs twice in a month. Guys, remember full moon and new moon occurs twice in a month. So this will also be seen twice in a month. Neap tides when earth, sun and moon are in quadrature position, then gravitational force of sun and moon act in opposite direction and overall high tide decreases, called neap tides. This occurs twice in a month. So guys, this is your spring tide, neap tides. This is about tides and all. Guys, uh, any subject in UPSC, you will always have some topics which you feel that needs to be done, this needs to be done. But I'm telling you, conceptually, whatever is important is done. Factual data I might have left. If you need any particular information with respect to that, you can always ask me. I have given. But guys, I'm telling you again and again, I am nowhere associated with administration aspects of Byju's. So please don't text me which class you have tomorrow, which where is that person, where is this person, I don't know. It's geography related. You can irritate me as much as you want. Okay? Yeah. That's what, ma'am. Corals will be covered with respect to, like, environment. Whichever is overlapping with other subjects I discuss, they will do it. That's why I'm stopping them. Guys, thank you, guys. Uh, you people had a lot of patience. So, if anything is required, just let me know. No, no, Bijo. Either full moon or either new moon will occur. Yeah, Anjali. Thank you. Thanks a lot. Okay. Yeah. I'll talk to them. I'll have some sessions if required. Thank you. Miss. ఇందులో పడిన లోపల